This video refers to your textbook on the Chapter 7 self-test. Here is question 1a, and the question is y equals x squared minus 8x plus 12. Geogebra will graph it right away for you. The question does ask you to just sketch it, so all you have to do is copy this. Now Geogebra will sometimes have parabola off the screen, so you're going to have to adjust. I'm zooming in here by rolling my mouse wheel, and then I'm going to take the move button to control the x-axis and the y-axis so I can see the whole parabola. Make sure you label in your sketch the y-intercept, the x-intercepts if there are two, and the vertex as well. Here's question 1b. The quadratic equation is negative 2 bracket x plus 1 bracket times x minus 5 in brackets. This quadratic equation is in factored form, but notice when I press enter, Geogebra will expand it for us and we get it in standard form. Here's the equation again in factored form, and you can see that by inspection the x-intercepts are x equals negative 1 and x equals positive 5. They're called zeros because the y value is equal to 0 when x is equal to these two values. Mark the key features of the parabola on your sketch. You should have marked the x-intercept at negative 1 and positive 5. Halfway between negative 1 and 5 is the axis of symmetry, and the vertex will be found on this axis of symmetry. To calculate the axis, let x be 2, and then substitute 2 into your original equation in factored form, and you will get that the y value will be at 18. Therefore, the vertex is at 2, 18. If you need to find the y-intercept, you let the x value be equal to 0. When you substitute x equals 0, you then calculate that the y-intercept is at 10. This parabola is in vertex form. The vertex is at negative 2, negative 7. It opens up because of the 0.5 is a positive number, and it is squashed to 1/2 the standard height. Here it is graphed. All these funny marks that you're seeing on the screen is me trying to rescale the x and y axes and moving it around. I've lost some of the details for the vertex, and I'd like to show you how you can graph this directly from the vertex form. The vertex is negative 2, negative 7. So here I'm moved over to negative 2 in the x direction and down to negative 7 and graph the point. Next, the point 5 tells me that it's going to open up and it's going to be half the usual distance. So normally, if I move off the vertex 2 units and I square it, I should go up 4 units. But in this case, I don't want to go all the way up to 4, but just to 2. So I've counted over 2 and up 2 and graphed point B. Next, because of the symmetry of a parabola, if I go from B to the axis of symmetry, and then 2 over again to the other side of the axis of symmetry, I can plot my other point, and that will be negative 4, positive 5. I'll get Geogebra to graph the parabola again. Here it is, graphed, and you notice that it goes through all 3 points. Here's the last parabola to sketch. The only thing I can pick out right away is that it's going to open down because of this negative 2, and it's going to be stretched 2 times in the downward direction. To make it more convenient, I'm going to factor it, and when I factor it, I get negative 2 times x plus 4 in brackets. So the zeros are at x equals 0 and negative 4. So here I have graphed my 2 points on the x-axis at 0 and at negative 4. Next, I determine that the axis of symmetry is halfway between negative 4 and positive 2, or x equals negative 2. And now I'm going to move up because I want to make sure that my parabola opens downwards, and I have to make sure that point C is going to be in a position where when I move 2 points off the axis of symmetry, the parabola will, instead of going 2 times 2, which is 4, it will go to 2 times 2, which is 4, and then doubled again because of that negative 2 in front. So if I go off by 2, I'm going to go down to negative 8. So here we go. So it looks like C needs to be in a position 8 up from the x-axis. I now get Geogebra to complete the parabola for me just to confirm. You can see now that the points do all lie on the parabola when graphed.